Hello everyone. Today's topic is linear differential equations. What linear differential equations are? Before we move on to linear differential equations, let's quickly recall differential equations. So differential equation is an equation that has derivative of a function, and when we solve the differential equation, we go back and find that function whose derivative is given in the equation. So far we have done variable separable differential equations where we separate x variable and y variable. We keep on the left hand side, right hand side, then we integrate and get the answer. Other one was a homogeneous differential equation. For homogeneous equation, we introduce a new variable v, so we write y is equal to vx, and then we solve it. The third type is linear differential equation. So if a given equation is neither variable separable nor homogeneous, we have to check for the linearity of that equation. Is it a linear differential equation? How do we know? If an equation takes this form, dy over dx plus pxy is equal to qx, means you have the first derivative of the function, you have y, that is function, px and qx. So the coefficient of y should be a function of x. If it is not there, means it is 1, then some qx, that is also function of x. So any differential equation that takes this form is called a linear differential equation. Now how do we solve this kind of equation? Before that, have a look at few examples. Dy upon dx minus y tan x is equal to cos x. So if you see, you have first derivative of the function, you have y, and negative tan x will be the coefficient of y, and there is some function of x on the right hand side, so it is a linear differential equation. And we can also see it is not a variable separable, nor it is a homogeneous equation, right? Similarly, this function, this equation, so you have the first derivative, you have y, and when you divide by this bracket, then it takes dy upon dx plus px y is equal to qx form, where px will be cos x plus sin x divided by cos x minus sin x, and q will be y. So this is also a linear differential equation. So if you're given a linear differential equation, how do we solve it? So this is the standard form of a linear differential equation. There are certain steps, and the good thing is for all linear equations we follow the same method, same process. What are these steps? Number one, find the integrating factor. What is the integrating factor? Integrating factor is e raised to the power of integration of this px. So whatever the coefficient of y is, after you write your given equation in this standard form, identify what is your px, and your integrating factor will be e raised to the power of integration of px dx. Usually px is very simple integration, so it will be very easy to find integrating factor. Second step is multiply the given equation by the integrating factor. So after you find the integrating factor, multiply this equation, the given equation, by integrating factor. Once you multiply, you will see a magic. What is the magic? After multiplication, it always becomes derivative of y times integrating factor on the left hand side. The right hand side will be some expression in x which can easily be integrated. Once you get this, the next step will be integrate both sides to get rid of this derivative, and you get your answer. Now how it looks when you solve a question, let's explore this with the help of an example. Here is an example. Solve the differential equation xy prime plus 2y is equal to this thing, where y1 is equal to 1 upon 2. So this is an initial value problem where we have to find a specific solution, right? So first thing what we do, we rewrite this equation in the standard form. So after you rewrite, you will get y prime is dy by dx. So you divide by x on both sides, so you get dy upon dx plus 2y upon x is equal to x minus 1 plus 1 upon x. So this is the standard linear differential equation where p is 2 upon x and q is x minus 1 plus 1 upon x. So next step will be finding integrating factor. When you find integrating factor, what will be integrating factor? Integration e raised to the power of integration of 2 upon x. So this is the linear differential equation whose integrating factor will be e raised to the power of integration of 2 upon x dx, and as I said, these integrations are usually very easy. So integration of 2 upon x will be 2 ln x, which is x squared. So next step is multiply given equation by your integrating factor. So when you multiply this equation or this equation, it's same thing, by x squared, what do you get? X squared dy by dx. On both sides you will multiply. X squared times left hand side is equal to x squared times right hand side. When you simplify, it will give you x squared divided by dx plus 2x squared y is equal to, when right hand side is multiplied, you get x cubed minus x squared plus x. If you look at this closely, x squared divided by dx plus 2xy, this is the derivative of x squared times y. So when you differentiate x squared y by product rule, you get this thing. It always becomes y times integrating factor, derivative of y times integrating factor. So can we rewrite this as derivative of x squared y is equal to x cubed minus x squared plus x, right? So now what is the next step? To get rid of this derivative, we will integrate both sides. So it was derivative of x squared y is equal to x cubed minus x squared plus x. Integrating both sides, you get x squared y is equal to integration of x cubed minus x squared plus x dx. And this is x4 raised to the power of 4 minus x cubed over 3 plus x squared over 2 plus a constant. This is the general solution of the given differential equation, right? But remember, what you were given was an initial value problem. That is, value of y is 1 upon 2 when x is 1. So we need to find a specific solution or a particular solution. How do we do this? Just plug in x is equal to 1 and y is equal to 1 upon 2 in this one. So C will be, when you put x1, y1 upon 2, it becomes 1 upon 2 is equal to 1 upon 4 minus 1 upon 3 plus 1 upon 2. So value of C will be 1 upon 12. Just plug in value of C out here and your final answer will be x squared y is equal to x raised to the power of 4 over 4 minus x cubed over 3 plus x squared upon 2 plus 1 upon 12. So this is your final answer. So that's how we solve a linear differential equation with the help of integrating factor. If you found this video useful, please consider subscribing, like this, subscribe it, share with your friends, and don't forget to press bell icon so that you are the first person to get a notification when a new video is posted. Till we meet again, take good care. Thank you.